All right, ladies and gents, I know it's been a really long day. Those notes took really long. I kind of warned you they would, but they happen. Like, that's how it works sometimes, right? So now is your opportunity to put this into action. So if you've been paying really close attention, taking good notes, and trying really hard to think about how this all fits together, this should be super easy for you. So we're going to walk through like the first 2 or 3 just to give you a sense of what the rest should look like. And then, of course, your homework is going to be to work on this and then finish the rest and be ready to take a quiz maybe by next class. Okay, so let's get to it. So first, we have your transformation. So we have it given to us in formal rule form, but we should be able to decode this. Go back to your notes. Let's decode this thing. So the transformation here is going to be a translation. So in other words, it's going to slide, because that's what that T stands for. It's backed up because we have this vector of movement 4, 5. We know this is going to be the pre-image, and it's going to map to the image. Okay, so we have this triangle ABC that's sliding along this vector 4, 5 to this new position. Now we should probably take a second and also decode the vector 4, 5. We know that correlates to XY, and so take a second, pause if you need to, go back to your notes and figure out what this is actually going to do. So 4, 5, because it's XY, means we're going to have the X plus 4 and we're going to have the Y plus 5. They're both positive on the vectors, and so we're going to increase both values. And so in terms of how they're going to move, X is going to be horizontal, and so this is really meaning that we're going to move this to the right 4, and then we're going to move it up 5. And so the entire triangle is moving up and to the right. And so when you talk about an informal translation, like what's it actually doing, using your own words, like that's what you should be focusing on. What's the big picture? And so the big picture here is that triangle ABC is going to be moving up and to the right. Like if you can say that, if you can look at that vector and you know which way it's moving, you've beaten most of this system. Like all the difficult parts of this, you've already taken care of. And so especially for a transformation, which hopefully you can recognize by that notation by now, if you can do that, you're good. Now what the formal translation means is we have to be a little bit more deliberate in what we talk about. And so like what we're going to say here is that triangle ABC, wow, that just all sorts messed up. Let's try that again. So triangle ABC is going to translate by the vector 4, 5 to map triangle A prime, B prime, C prime. And so like one of these phrases is what you'll see on a test, one of these phrases is what should be going on in your head. I'll let you decide which one's which. Okay, so either way, one has a vocabulary, one doesn't, but they mean the same thing. So it's going to translate, slide, move, and maybe we should say slide here. It's going to slide up and to the right. Otherwise, you're moving it by the vector 4, 5. So in part C, you have to decide the algebraic rule. Now, hopefully you have that cheat sheet from the sub by now. If you don't, make sure you pause this, go get it, because you're going to need it, not for this one, for the ones coming up next. And so now we're going to map these points. And so the vector 4, 5 means that we're adding both to the x and y values, as is shown by this rule right here. And so we have some space kind of in the middle to make this happen. And so we're going to take the x plus 4, so we're going to take the negative 4 plus 4, and we're going to take the current y, which is negative 1, and we're going to add 5 to it. And so the new mapping for A prime should be negative 4 plus 4, which is 0, negative 1 plus 5, which is 4, and we should map that immediately down here. Now, we're trying to help you out, so obviously we're going to kind of make sure that you have this first one graphed right, but we should go ahead and double check. So 0, 4, that means we start at 0, we go straight up 1, 2, 3, 4. Please take note of how this is numbered. Each individual little box doesn't stand for 1, each of these bigger, thicker ones do. And so we do have the correct coordinate here of 0, 4, so we can trust that A prime mapped properly. Okay, so hopefully you did the work, and so you can compare it. All right, so let's do the next one. So negative 3 plus 4. Negative 3 plus 4, negative 3 plus 5 from our transformation rule, and so we end up with 1 negative, oh sorry, not negative, 1 2. So 1 2, which we can confirm for B prime over 1 up 2. Yep, that's 1 2, so that ended up in the right place. Okay. And then the last one, we're going to take 0 plus 4, negative 1 plus 5, and that maps now to 4, 4, and we can check it. 1, 2, 3, 4, up 1, 2, 3, 4. Yep, C prime is in the right place, 4, comma 4. Now, these vectors, like I said, were pre-drawn. And we were trying to make sure that for these first couple examples, you had the best version of the answer. But in the event that you don't have these vectors, you guys know how to draw them in. So like when we talk about a vector, we're talking about these guys right here, vectors. And we know that from our experience and the notes, the vector relationship is clear. These vectors should be parallel, as denoted by these chevrons, which you're adding to yours as well. And they're also congruent. And so remember, it doesn't matter how many tick marks or how many parallel marks I use, they just have to map. And so that's what it looks like as a whole problem. So we have to decode, we have to be able to explain it both in terms of like how you're going to see it like in math class, but also how it makes sense in your head informally. We got to pick the right algebraic rule, but you have a cheat sheet and you have notes to help you do that. You're going to have to now take the old points, translate the rule to the new points, plot them, and then mark vectors, parallel, perpendicular bisectors, or circles and angles in order to track it. Okay? So that's the whole ball game. So if you can do that, you're going to win. Let's do this one. Remember, if that was too fast, go back, watch it again. It's a video. Decoding first. So right here we had this big R. Now in notes we just took, the big R meant reflection, but if you look at the information here, this actually has to mean rotation, because the information we have here is an angle of rotation, which again we're assuming is counterclockwise, and so this way. That's counterclockwise. And then we have a center of rotation, which is just O, and again that means origin, the exact center of the grid, which is 0, 0. So there you go. So what's happening here? Well, we're definitely going to be spinning or rotating. So we're going to be turning. So we're going to be turning the triangle 90 degrees counterclockwise, about 0, 0. Okay? And so the formal translation is going to sound actually going to sound almost the same. So we're going to take the triangle ABC. It's going to map to triangle A prime, B prime, C prime by rotating 90 degrees counterclockwise about the origin. Okay, so it says the same thing, just a little bit more formally, which is again this kind of game we have to play sometimes in school and in math. And so we have to select the correct rule, but it's been selected for us. And in the future examples, you'll have to write that one in. Again, you have a cheat sheet, and so if you read that, you should have different rules, because this is a rule specifically for the origin and 90 degrees counterclockwise. And so in terms of what we're going to have to do, so we're going to have to flip. Okay, so we're going to flip the XY, and then we're going to change the sign here, and then we're going to keep the sign here. Okay, remember, this is the one that is super easy to mess up. So I'm going to go ahead and copy, probably pull up, ooh, like that. Okay, there we go. I'm just going to make it big there. Okay, so let's go ahead and map this out. So -2, -2, -3. First, we're going to flip it, and so these two are going to change, and then we're going to change the sign for the first one. So that's going to change to +3. The -2 got flipped to the back. It's going to stay -2. So let's see if that actually mapped. Whoever did this mapped it the right way. So that was for C. Looks like it was a Chicago fan because it spelled out Cub. So C is going to map to C prime for like 1, 2, 3, and then down 2. Yep, so that's going to be 3, -2. That was mapped properly. Good job, Cub fan. For the next one, again, we're going to flip. So let's flip those over. Change the sign from the first one to a 1. Keep the sign on the -5. The one got kicked to the back. And we'll see if U got mapped to U prime properly. So it's going to be 1, -5 over 1 down 5. Yep. So that's going to be 1, -5. So we're 2 for 2, Cub fan. Last one more flip and one more change sign. So the 1 was at the back, got flipped to the front. So the -1 got flipped to the front and becomes a +1. The -1 got flipped to the back and stays a -1. So over 1 down 1 to 1, -1. Let's go ahead and draw that new triangle, shall we? And so B prime, U prime, C prime, and back. This one is like super hard to see, so I'm going to go ahead and also highlight it. And you should do that too. I have highlighters over on the counter. You're welcome to do that too. But here we have again an orbit. Like this again, it looks proper. We should mark a couple things that are important. That's going to be our center of rotation, which is going to be 0, 0. But we should also trace, so we should also honestly go back and trace the angles because we should confirm that these are 90s. And so B went to A, then back to B prime. That looks like a good angle, and again, it does look like they're congruent. The purple, what's that going to be? U. So U, oops. Okay, so U to A, center of rotation, over to U prime. Again, that looks like a good 90 and also looks congruent as well. And until we can calculate those, I mean, that's all we can really do is take our best guess for rotation. C to A over to C, we got that 90, we got that congruency. And so we definitely have a nice rotation there. Okay, that's it. And so the question here, how are circles related to the pre-image and image points? Well, hopefully you notice that each point and its image and pre-image gets their own circle, get their own orbit. I keep likening this to kind of orbiting the sun because it just kind of looks like the universe to me. So like B is kind of like the Earth, Mercury, right? It's first close to the sun. B rotates to B prime along its orbit, C to C prime along its orbit, and U to U prime along its orbit. And if you can kind of conceptualize that, again, you won the game. Let's do one more, and then I'm going to turn you all loose. So even without the picture, because now we can get the picture, let's do some decoding first. Here we have a little r, but we're immediately told x-axis. And so that's going to be a line, and so this is going to be our line of symmetry. Also, line of reflection. Because in this case, a little r is going to stand for reflection. And so they will try to trick you by changing big R, little r, and sometimes they'll just use a capital T to stand for everything. And so you just got to kind of be aware of that. And so this is going to be a reflection, in other words, a flip. We're going over the x-axis this time, which is kind of interesting. So we're going to, instead of flipping left and right, we're flipping up and down. It's going to take our pre-image and map it onto our image. Yeah. Okay. So let's talk about the informal translation. So what's happening? Well, we're going to flip the triangle. And if we're flipping over the x-axis, you know, this guy right here, we're going to flip the triangle down. I mean, I think that's all that's going to happen. We're going to have a triangle here, and we're going to end up with a triangle down there. It's flipping down, or it's going to be flipping up, depending on which one it is. So instead of flipping left and right, we're just going to be flipping up and down. But what's really happening? How should we talk about it? Well, triangle ABC will map to triangle A prime, B prime, C prime by reflecting over. Sometimes it's weird, but sometimes you'll actually hear him say reflect in a line. Like that doesn't make sense to me. I always think of it as flipping over or about a line, but sometimes you will hear him say in. And those people are weird, but they exist. So ABC will map onto triangle A prime, B prime, C prime by reflecting over or about the x-axis. So that's what's going on. So we're just flipping. Oh, that's how you spell axis. AXIS. There we go. Okay, so we're just flipping over the x-axis. And so again, we got to select the right rule. And this rule, if you know, again, I told you they were different every time you did a different kind of reflection. This rule is different. And so we have to kind of reinterpret it. But it's not going to be hard to interpret it because you guys know what's going on here. And so looks like X is going to stay X. Looks like Y is going to stay where Y is. But we are going to have a negative here, which means we're going to change the sign. So this is going to stay the same. And then we have to change the sign over here. So change sign. That's it. And so we can do that 3 times. We're golden. So 1, 3 is going to become 1 because 1's staying the same, but we're going to change it to a -3 because we have to change the sign on the second one. And let's see if BHS, and let's see the B prime is in the right place. So we got to go over 1 and down 3 because it's a negative, and it's in the right place. So 1, -3. Let's go with green. So we're going to keep it in the same order. Keep the sign the same on the first one, flip the second sign, so +1 becomes a -1. And so if we graph it out 3 down 1, yeah, that works. So it's 3, -1. And then look at orange. And so we're going to stay the same on the 6, change the sign on the 2, and so over 6 down 2, 6, -2. Yeah, those are all in place. And so if we go ahead and draw on a new triangle, to BHS, we definitely have a reflection, at least what looks like a reflection, right? So this, we should probably do some labeling here, just like always. You should do it on the subsequent problems too. This is going to be our axis of symmetry, which is also called our line of reflection. Okay, and so remember, that's also got to be a perpendicular bisector. So it's also going to be a perpendicular bisector. And so we should mark that. So perpendicular means we're going to form right angles each one. Bisection means we're cutting these each in half. And again, you can count it. And so kind of the cool advantage of being on a graph is like we don't have to calculate the distance, we can calculate it. Like this distance is just 2 because we can count it, and so is this. That distance is just 1, and so is the one at the bottom. This is a distance of 3, and that's a distance of 3 also. And so we can see right away that it is a perpendicular bisector. And guys, that's it. If you can do that, you can have high success moving into this next section. And so you're going to have to do everything we did in the notes. I mean, this is almost exactly like it. And guess what? When I give you guys a quiz next class, guess how the quiz is going to be formatted, and guess what you got to be able to do, right? So work the remaining, like I think there's like 6 problems left or so. The difference is, if you notice, we may not give you the rule every time. We may not give you the vectors or whatever each time. So you're going to have to select the right one. And so work hard. Ask questions. If you are confused about something that is reasonable, just make sure you come back with questions. Like, so don't come back blank. Come back with as much as you can possibly do. And I'll tell you right now, I do have sympathy if you come back and say, well, I don't understand what this part was, but I did as much as I could, versus you come back and say, well, I didn't know what to do, so I just didn't do any of it. Well, what that means is that you probably did know a lot, you just were kind of being lazy. So please don't be lazy, work hard. I know I'm not there, but work hard. You guys are smart people. You'll figure this out, all right? So I'll see you guys in a couple days. Have a wonderful weekend.